what we are going to learn in this lecture? Meaning of dispersion and calculation of different measures of dispersion. But before knowing the meaning of dispersion, let's begin with the story of a person who has to walk across a stream along with the other members of his family. The person inquired about the average depth of the stream. On being informed that it was 1.5 meters on an average, the person felt that the members of his family could walk across the stream to the other bank of the stream because they were all taller than 1.5 meter. However, while crossing the stream, some of the family members got drowned. Can you find out why they got drowned when their height was more than the average depth of the stream? You have only to realize that an average depth of 1.5 does not mean that the stream has a depth of 1.5 meter everywhere. At some points it is much less and at some others it is much more. The average value gives us the central value, but it does not give us any information about the spread of the actual values around that central value. This spread of the observed values is known as dispersion. So, here comes the meaning of dispersion. Dispersion is the degree of variation in the data. The extent to which the numerical data in any distribution differ from among themselves is a measure of dispersion. Now, some measures of dispersion. Measures of dispersion may be broadly classified into: first, absolute measure of dispersion. These are expressed in units in which the original data is expressed. These are further classified into range, mean deviation, standard deviation and quartile deviation. Second measure of dispersion is relative measure of dispersion. These relative measures are measured as ratios or percentage relative to the average. They are independent of units in which the data are expressed. These are further classified into coefficient of range, coefficient of mean deviation, coefficient of variation and coefficient of quartile deviation. Now, let's discuss each of them in detail. First one was range. It is one of the most simple and commonly understandable measure of dispersion. It is defined as the difference between the highest and lowest observed value. So it is given by the formula range is equal to highest observed value minus lowest observed value. So let's do a question for practice. Calculate range of the following series. Size is given and frequency of different sizes is given. It is a case of discrete series, and in case of individual or discrete series, range is calculated by the simple formula. That is, here highest value is 16, lowest value is 9, so range is equal to highest value minus lowest value, that is 7. Also, if in this question we have to find the coefficient of range, it would be coefficient of range is equal to highest value minus lowest value divided by highest value plus lowest value into 100. So it is 16 minus 9 upon 16 plus 9 into 100. That is 7 by 25 into 100, which is 28. Our second question is, what is the range and its coefficient for the following distribution of weights? Here weights are given in the form of class intervals and their corresponding number of students is given. It is the case of continuous series. Here range is the difference between the upper class boundary of the highest class and the lower class boundary of the lowest class. But first we will convert the series into exclusive frequency classes. So converting it into exclusive frequency classes, take the difference of any upper class limit and its succeeding lower class limit. So take 55 minus 54, that is 1, and divided by 2. So it comes to 0.5. Now subtract this 0.5 from every lower class limit and add this 0.5 into every upper class limit. So the weights will be 49.5 to 54.5, 54.5 to 59.5, and so on. So here the highest class boundary is 74.5 and lowest class boundary is 49.5. So range is equal to 74.5 minus 49.5, that is 25 kgs. Now coefficient of range is equal to 74.5 minus 49.5 divided by 74.5 plus 49.5 into 100. So it comes to 20.16. Second is mean deviation. Since range is based on only two observations, it is not regarded as an ideal measure of dispersion. So a better measure is mean deviation, which is based on all the observations. So mean deviation is the arithmetic average of the deviations of the observed values from an average of these observed values. It is given by the formula mean deviation is equal to sigma x minus x bar upon n. And in case of group frequency distribution, mean deviation is equal to sigma f into x minus x bar upon sigma f. Also, coefficient of mean deviation is equal to mean deviation upon mean into 100. Coming to our next question is, the expenditure on stationery by different students is given below along with the number of students spending that amount. We have to find the mean deviation of this distribution about the mean. Here is the required table. Expenditure is given in the form of rupees and number of students spending that amount is also given. As we know, formula we have to use here is mean deviation is equal to sigma f into x minus x bar upon sigma f. So our first column will be of expenditure, that is x. It is 36, 48, 60, 72, 78 and so on. Second column will be of number of students, that is f. So here 4, 8, 12, 18 and so on. Third column will be of fx. Why fx? Because first we will have to calculate mean, which is sigma fx upon sigma f. So we will calculate here fx, x into f. 36 into 4, 144, 48 into 8, 384, 60 into 12, 720 and similarly for other values. Now mod of x minus x bar. Why this mod? Because it means we have to take the positive value only. While calculating the mean, it comes to sigma fx upon sigma f, that is 75. So for first value, x is 36, 36 minus 75 is minus 39, but we will take 39. Similarly, 48 minus 75 is minus 27, but we will take 27. 60 minus 75 is minus 15, but we will take 15 and so on for other values. Last column is of f into x minus x bar. Means we have to multiply f with each corresponding value of x minus x bar. So 4 into 39, 156, 8 into 27, 216, 12 into 15, 180 and similarly for other values. These are for remaining two values. So we will do the sum of sigma f for sigma fx and for sigma f into x minus x bar. So putting the values in the formula of mean deviation, we get our mean deviation as rupees 12.12. And if we have to calculate coefficient of mean deviation, it is mean deviation upon mean into 100. So it is 12.12 upon 75 into 100, that is 16.16. Moving to our third measure of dispersion, it is standard deviation. In the case of mean deviation, absolute values of deviations are taken, but in the case of standard deviation, squares of deviations are taken. So standard deviation is the square root of the arithmetic average of the squares of the deviation measured from the arithmetic mean of the data. It is an important and most popular measure of dispersion. It is given by the formula standard deviation is equal to square root of sigma x minus x bar whole square upon n. And in case of group frequency distribution, its formula is standard deviation is equal to under root of sigma f into x minus x bar whole square upon sigma f. Also, coefficient of standard deviation is equal to standard deviation upon mean into 100. Sometimes the square of standard deviation, known as variance, is regarded as a measure of dispersion. Therefore, variance is equal to standard deviation whole square. Now let's do a question for practice. Find the standard deviation from the following data. Data is marks are given in the form of class intervals and corresponding number of students are given. Now, since it is a case of group frequency distribution, standard deviation will be calculated by taking mid values of class interval. First column will be of marks, which is in the form of class interval, that is 0 to 4, 4 to 8, 8 to 12 and 12 to 16. Second column will be of frequency, that is f, 4, 8 to 1. Doing it sum comes to 15. Third column will be of mid value of x. As you all know how to calculate the mid value, 0 plus 4 divided by 2, that is 2. 4 plus 8 divided by 2, that is 6, 8 plus 12 divided by 2, that is 10, and 12 plus 16 divided by 2, that is 14. Now, taking fx, that is 4 into 2, 8, 8 into 6, 48, 2 into 10, 20, and 1 into 14, 14. Its sum comes to 90. Next column will be of x minus x bar. X bar is sigma fx upon sigma f, that is 90 upon 15 is equal to 6. So x is 2 and x bar is 6. 2 minus 6 is minus 4. 6 minus 6, 0. 10 minus 6, 4, and 14 minus 6 is 8. Next column will be of x minus x bar whole square. So minus 4 whole square 16, 0 square 0, 4 square 16, and 8 square 64. Next column is of f into x minus x bar whole square, that is 16 into 4, which is 64, 8 into 0, 0, 2 into 16, 32, and 1 into 64 is 64, and its sum comes to 160. So, as we just calculated, x bar is 90 upon 15, that is 6. Standard deviation is equal to under root of sigma f into x minus x bar whole square upon sigma f. Putting the required values, it is under root of 160 by 15, that is 3.265. Our next question is, if arithmetic mean and coefficient of variation of x are 10 and 40 respectively, what is the variance of 15 minus 2x? Here, coefficient of variation is 40 and mean is 10 given in the question. And we all know coefficient of variation is given by the formula standard deviation upon mean into 100. Putting the required values, we will get standard deviation as 4. So, standard deviation of 15 minus 2x is 2 into 4, that is 8. So, variance of 15 minus 2x is 8 whole square, that is 64. Now, our next concept is combined mean and combined standard deviation. Sometimes, two or more series are combined and a combined mean and combined standard deviation of such series is calculated. And we have just studied formula for combined mean in our previous lecture. It is n1 into x bar 1 plus n2 into x bar 2 plus n3 into x bar 3 whole upon N1 plus N2 plus N3. Similarly, there is a formula for combined standard deviation. It is given by under root of N1 into sigma 1 square plus D1 square plus N2 into sigma 2 square plus D2 square plus N3 into sigma 3 square plus D3 square upon N1 plus N2 plus N3. So let's do a question for this. A shopkeeper mixes a batch of 200 apples of mean 150 gram and standard deviation 30 gram with another batch of 300 apples of mean 100 gram and standard deviation 20 grams. Find the mean and standard deviation for the combined batch of 500 apples. Here the combined mean is given by this formula. So combined mean is 200 into 50 plus 300 into 100 upon 200 plus 300. So it comes to 120 grams. Now we know the formula for combined standard deviation. It is this. But first we will calculate D1 and D2. D1 is 120 minus 150, that is 30, and D2 is 120 minus 100, that is 20. So putting the values in this formula, we will get our combined standard deviation is 34.64 grams. Now our fourth measure of dispersion is quartile deviation, or also known as interquartile range. What is it? It divides the series into 4 equal parts and measures the distance between the third quartile and the first quartile. So it is given by the formula QD is equal to Q3 minus Q1 upon 2, and also coefficient of quartile deviation is given by the formula Q3 minus Q1 upon Q3 plus Q1 into 100. Let's do a question for this. Following are the marks of 10 students. Find quartile deviation and also its coefficient. Here are the marks of 10 students. Let's solve it. First we will arrange the marks in ascending order of magnitude, and we will get it as this: 35, 42, 48, 50 and so on. Now value of Q1 is n plus 1 by 4th observation, that is 10 plus 1 by 4th observation. So it is 2.75th observation. It means second observation plus 0.75 into difference between third observation and second observation. It is 42 plus 0.75 into 48 minus 42. So it comes to 46.5. And similarly Q3 is 3 into n plus 1 by 4th observation, that is 8.25th observation. So it comes to 65 plus 0.25 into 10, that is 67.5. But now we have to calculate QD, that is Q3 minus Q1 upon 2. So it is 67.5 minus 46.5 divided by 2, that is 10.5. Also, coefficient of quartile deviation is Q3 minus Q1 upon Q3 plus Q1 into 100. So it is 67.5 minus 46.5 whole upon 67.5 plus 46.5 into 100. So it comes to 18.42. Now, you all must try all questions of exercise 11.13 of your study material and ask query if any.